All right, folks, so now for this same problem, we are going to find the RRAM, or the right rectangular area method. So for the LRAM, we started on the left side of interval and started making our heights. For RRAM, or the right rectangular area method, we are going to start from the rightmost point and start making our heights. So what's weird about this one is when we start with this right point and we make our height to the next interval, we see that this actually isn't a rectangle. It doesn't have any area because there isn't any height. It just continues to sit right on the x-axis. I move up to my next point and draw my height. I'm going to go ahead and color in that rectangle. Then my next point is my height. Color down. And then the next point is the height. Color down. So even though we only have 3 rectangles with area, we still have broken up the interval into 4 different rectangles. It's just, this one here doesn't have any area. So looking at those blue rectangles we have colored in, it looks like RRAM is going to be an underestimate, as opposed to our LRAM, which was going to be an overestimate of the actual area. So for the RRAM, our base of each of those rectangles is still going to be 0.5. So there's our base. And now we are going to find each of the heights of those rectangles. So if I look at this first blue rectangle, its height comes from this dot, which is f of 0.5. My next rectangle has a height that comes from this dot, or f of 1. My next rectangle has a height of this, which comes from that dot, or f of 1.5. And then my last one, f of 2. So, just to compare to LRAM, LRAM started with the leftmost point with making the heights of our rectangles, but then RRAM started with the rightmost point. So the way that you start each of those rectangles is important for the name, whether it's LRAM or RRAM. So now I'm going to go back to my calculator, and actually a lot of these values we already have found in the previous problem. So f of 0.5 is 3.75. And then f of 1 is 3. F of 1.5 is 1.75. So the only one I don't know is f of 2, but if I go back to my graph, we can see that f of 2 is 0. Now, I've intentionally goofed here because this is one of the more frequent mistakes that I see on the test. A lot of times students will just straight up add those together and they'll forget to multiply it by the base. So remember, folks, we got to have that 0.5 out in front because that's the base of each of those rectangles, and we're essentially doing distribution. Base times height, base times height, base times height, base times height. And notice that since this height is 0, that's why we don't actually get an area there. So typing this in on the old calculator, we get 0.5 times 3.75 plus 3 plus 1.75 plus 0. And we get 4.25. So the RRAM is 4.25 what? Units squared. Remember, got to have that unit squared there because we have found area. So now comparing these two, 6.25 we've said is an overestimate of the actual area under that quadratic. The RRAM is an underestimate. So one thing that we can do if we are finding both LRAM and RRAM for a given problem is we can find a kind of best estimate by taking the average of those two. So here, if I take 6.25 plus 4.25 and I divide by 2. That is how you find an average. And again, make sure you trap those binomials in parentheses. I would get 5.25 units squared. And we would say this is the best estimate of what the actual area is under the curve. Now, in most of these problems, we're not going to be looking for the best estimate. We're just going to be finding both LRAM and RRAM, or one or the other. And again, folks, all of what we are doing here is an approximation, but in calculus, what you will be doing is using this nasty little formula that we already talked about, using limits to find the limit as the number of rectangles approaches infinity. So again, using limits to find an exact value. All right, folks, so that is it on example 1. In the next video, we'll look at example 2.